Welcome students. Today we are discuss about the unit number 3, 8085 instruction set, and today we are discuss the topic branching instruction. Student will be able to learn the following objective from this lecture: branching instructions, conditional jumps, and unconditional jump instructions. Branching instruction. The branching instruction is referred to the act of switching execution to different instruction sequence as a result of executing a branch instruction. The three types of branching instruction are there: jump instruction, so conditional and unconditional jump, call, unconditional call and conditional call, return, unconditional and conditional. Jump instruction. The jump instruction is transfer the program sequence to the memory address is given in the operand based on the specific flag. And jump instruction are two types: unconditional jump instruction and conditional jump instructions. Unconditional jump instruction is transfer the program sequence to the described memory location. Unconditional jump, JMP. Okay, so jump at given location. So here is JMP. Whenever the jump instruction is execute, okay, it is jump to the particular location. As we given the example, jump 2050. So 2050 is a location. So whenever this instruction is execute, okay, so microprocessor is transfer the control at given location 2050H. Conditional jump instruction transfer the program sequence to the described memory address only if the condition is satisfied. The conditional instruction. So first one is JC. Okay, jump if carry. Okay, so jump to the address if the carry flag is to 1, as shown in example JC 2050H. So whenever the ALU is performed the arithmetical operation and logical operation, and suppose the carry is generated, then okay, the microprocessor is transfer the control to the given location. Same like JNC, jump if not carry. So whenever the ALU is performed the arithmetical and logical operation and the carry is not generated and carry flag is become 0, so then it is jumped to the given location JNC 2050H, means carry bit is 0, then it is jumped to the given location 2050H. JZ, jump if 0. Okay, so micro processor is jumped to the its control to the given location whenever the 0 flag is set to 1. JNZ, jump if not 0. So the microprocessor is transfer the control to the given location when the okay, 0 flag is reset. JPE, okay, jump to the address if the parity flag is set to 1. So JPE 2050H. So the microprocessor is transfer the control at given location. JPO, jump if odd parity. Okay, so when your parity is odd, then it is jump to the given location. JM, jump to the address if the sign flag is set to 1. Okay, and JP, jump to the okay address if the sign flag is reset. Okay, so JP 2050H. So whenever the arithmetical and logical operation is performed by the ALU, okay, and the sign flag is reset, then it is jumped to the at given location 2050H. So all the instruction is a conditionals. So whenever this condition is fulfilled, then and then, okay, our microprocessor is transfer the control at given location. Call instruction. The call instruction is transfer the program sequence to the memory address is given the operand before transferring the address of the next instruction. Okay, after the call is pushed onto the stack, and the call instruction are there are two types: unconditional call and conditional call. Unconditional call instruction, it transfer the program sequence to the memory address is given operand. So this is the unconditional call. So call and address. Okay, so whenever this instruction is execute, okay, So microprocessor is transfer the it control at 2050H address. So this instruction doesn't require the any condition. It is the unconditional call. So whenever this instruction is executed, the microprocessor is transferred its control at given location. Conditional call. So the conditional call means whenever the condition is fulfilled, then and then microprocessor is transferred its control at given location. So all are the conditional instruction. CC, call if carry flag is set to 1. So given example is CC2050S. So whenever the carry flag is set to 1, the microprocessor is jumped to the at location 2050H. CNC, jump if not carry, means whenever the carry flag is reset, so it is jumped to the given location 2050H. CZ, okay, call if, okay, zero flag is set to 1. So the example is CZ2050H. So whenever the zero flag is set to 1, the microprocessor is transferred its control at given location 2050H. CNZ, okay, call if zero flag is reset. So whenever the ALU is execute the arithmetical operation as well as logical operation, and suppose the zero flag is reset, then whenever this instruction is execute CNZ 2050, okay, so the microprocessor transfer its control at given location. Okay. CPE, call if parity flag is set to 1. Okay. Then CPO, call if parity flag, okay, is reset. CM, call if sign flag is set to 1. And CP, call if sign flag is reset. Return instruction. The return instruction is transfer the program sequence from subroutine to the calling program. And return instruction are there are types, two types: unconditional jump instructions and conditional jump instructions. Okay. So unconditional return instructions, the program sequence is transferred the unconditionally from the subroutine to the calling program. So this is the return. So return instruction, whenever the return instruction is executed, okay, so it is unconditionally. So whenever we calling the subroutine, okay, so after the completion of the subroutine program, okay, with the help of this instruction, we go for the back to into the main program. Conditional return instruction, the program sequence is transferred unconditionally from the subroutine to the calling program, only the conditional is satisfied. So whenever the condition is satisfied, then and then, okay, the program is the microprocessor is transfer its control from subroutine to main program. So all instruction are conditionally, okay. So RC is written from the subroutine if the carry flag is set to 1. Okay, the example is RC. Okay, then RNC, written from the subroutine if the carry flag is reset. RZ, written from the subroutine if the zero flag is set to 1. RNZ, written from the subroutine if the zero flag is reset. Okay. RPE, written from the subroutine when the parity flag is 1 or even. RPO, written from the subroutine if the parity flag is reset or odd parity is there. RM, written from the subroutine if the sign flag is set to 1. And RP, written from the subroutine when the sign flag is reset. Thank you.